composite functions, or could be called composition of functions. It's basically when you take two functions and make a new one, but it's not like the adding or subtracting, multiplying or dividing that we've done before. Composite functions are formed from two functions when the output of one function is used for the input of the other function. So if we look at this one that's given, f of x is equal to 4x, g of x is equal to x plus 6, and h of x is equal to x squared, we're going to figure out each value. There's two different ways to write a composition of functions. This first one says f of g of 3. Another way to write that would be f of g of 3. Sometimes you'll see it written like that. With that, it's not an O, it's smaller than an O in the middle there. It's like a little circle, but it's not just a dot for multiplication. It's like somewhere between an O and a dot. F of g of 3. But I like writing it this way with the multiple brackets because it kind of makes more sense to me what we're actually doing. When you see f of g of 3 written out like that, it doesn't give you really any indication of what you're going to do unless you already know that notation. But when you see it written out this way, it kind of tells us exactly what to do. It says it's just like when you have multiple brackets like in an expression, you look at the innermost brackets first. So the inside brackets say find g of 3. So that's what I'm going to start with, is just finding g of 3. G of 3 means take that function g and do what with it? Put 3 in for x, right. So we're going to go 3 plus 6. And then 3 plus 6 is 9, and then it tells us to find f of 9. So without even really knowing what the composition of functions is really all about, as long as you can follow the order of operations, which says do those inside brackets first, you should be able to do this. Because then to find f of 9, you just take that f function and replace the x with 9. So that's equal to 4x, or 4 times 9, so 36. So the output for g of 3 was 9. That's what we had for g, and then we use that as the input for f. So we find the 9 from the g function and use that as the x and the f function. Anytime that I have a composition of functions, I'm going to write it like this, in this form with the brackets instead of the f of g. It's still the same thing, but it's just, to me, it makes a lot more sense. So if we look at the second one there, g of f of 3, which, again, this could be written as g of f of 3 like that, but I prefer the other way. This tells us, innermost brackets say, find f of 3. So f is 4x, so that means 4 times 3. We need to then find g of the output from f, which is 12, so g of 12. And g is x plus 6, so it's 12 plus 6, or 18. G of h of negative 2 means we're going to do h of negative 2 first. So negative 2 squared. And negative 2 squared is 4, so then that becomes the input for g. G of 4 is 4 plus 6, so it's equal to 10. You guys were right. So for this second one, the f I'm just going to leave for now, and the g, but we'll do this h of 0. H is x squared, so 0 squared. So then we have to find f of g of 0. G of 0 would be 0 plus 6. So then we want f of 6. and f of 6 is equal to 4 times 6, or 24. Here's a bit of a different question, but related to the same thing. It says if f of x is equal to x plus 1, and g of x is equal to x squared, determine the equation of the composite function g of f of x and sketch its graph. So f of x is x plus 1, that's that linear function there. G of x is x squared, so that quadratic. And then the composition g of f of x is also graphed here. But let's see what the equation of it is. We want to find g of f of x. So we don't have a value to fill in for x. We're just going to fill in the function f of x. So we're finding g of x plus 1. Which means, this does get a little bit confusing sometimes because you're replacing x's with something else in terms of x. But this is telling us in the function g, put x plus 1 in the place of x. So g of x is x squared. G of x plus 1 then is x plus 1 squared. You could leave your answer like that if you want, because that's actually vertex form for that quadratic function, or you could expand it to be x squared plus 2x plus 1.